many, or how are the mid-segments of a triangle related to the sides of a triangle? Well, here's the deal. Mid-segment, midpoint, we're kind of at the halfway point, right? Okay, so think halves today. Okay, this is pretty simple. I'm going to be honest with you today, all right? Very simple stuff today. Okay, here we go. Goals today. First one, you've got it. Bridge, you got the first one?
I got him. Which one? Mid-segment?
Mm-hmm.
Oh, that one. Use the mid-segments of triangles in the corner.
Okay. Now we're also going to use the triangle mid-segment theorem to find what?
Distance.
The thing you're going to find out today is if you know one distance on a bigger part, the corresponding distance or the parallel distance from the mid-segments is half the distance. Okay? So a mid-segment, what the heck is it? How about a volunteer to read a mid-segment for me?
I got you.
Okay.
A segment that connects the midpoints of two sides of the triangle.
All right. Can I move this? Yeah. Here we go. Yeah, you're right. It's a segment that connects the midpoints of two sides of a triangle. So if I had a triangle definition-wise, if we had a triangle definition-wise, here's a triangle. Okay? If you would pick the midpoints on this right here, say maybe a midpoint is here, midpoint here, midpoint here. We're going to form a triangle with the three midpoints. Okay? Check this out, kids. This segment right here with the midpoints, how do these two lines on the far left and this red line just look like? What do they look like? Parallel. If I would slide this all the way over to here, it's going to be half the distance of this left side, okay? This is what's formed in here by it, okay? So when we talk about what's a mid-segment is just going to connect midpoints of the sides of a triangle, okay? You know what a midpoint is? The formula's over here. You've seen a visual of it before, so I'm not going to waste your time, but quickly I'll read through it. In geometry, the midpoint is the what? Middle point of a? It is, what's the word? From both endpoints, and it is the centroid both of the segment and of the endpoint. It also does what? Lot there. You guys know what parallel means, right? Two lines that extend infinitely forever, never ever do what? Okay, remember we put these little symbols in there to indicate parallel lines. What's the definition of slope? Rise over run. Another formula we might have to revisit is m equals y2 minus what? Over. Okay. And then coordinate proof. Coordinate proof is simply something that we're going to look at in a Cartesian plane to make an argument. Okay, we're going to talk about using variables as our coordinates instead of actual values to make arguments about geometry concepts in a Cartesian plane. Okay, let's see what we've got here. Example 1. It's kind of hard to see, but you should be able to read this on your notes pretty well. Using mid-segments in a coordinate plane, I'm going to blow this up. Ready? Boom! Good. It says in triangle RST, show that the mid-segment MN is what?
Parallel.
Okay, we've got to show MN is parallel or what? Okay, so the first thing we're going to do is show that MN is parallel to what? Okay. How do you show lines are parallel on a Cartesian plane, or in a coordinate plane, if you will?
The little arrow.
You could, little arrows, but what must be the same if the lines are going to be parallel? So if I can find the slope of both of those lines and show that the slope of those lines are same, then that means those lines are what?
Parallel.
Yeah, let's check it out. So let's find the slope from R to S. Slope from R to S. What's the rise from R to S, or S to R, if you will? Help me count. It's hard for me to see this up here. I think it's rise 1, 2, 3. Is there a rise of 4?
Yeah, and then over 4, too.
Rise of 4, run of 4?
Yeah.
Slope is what?
1.
1. Okay, check your slope, small m from n to m. What's the rise? Looks like 2. Run 2. Oh my gosh, how does the 2 and 2 compare to the 4 and 4?
It's the same.
Holy smokes, it's the same slope, but how do the 2's compare to the 4's?
They both divide into 1.
Half of it, right?
Both half of it.
But, yep. What's true about my slopes, kids? Slopes are the same, so what's true about those two segments, RS and NM?
Parallel.
Slopes are equal. So what? So we would say, so MN is parallel to what? Okay? That's the first thing we had to show. Then, it said show that MN is half of how much? Okay, well, we got to use distance formula on this. Okay? M and N, R and S. We can just use Pythagorean theorem on this.
Oh, I know.
Okay, MN, listen carefully.
I know the term.
You could use distance formula or you can just count. Should we just count?
Yeah.
You don't even have to use the big
Let's use the
formula.
distance.
You could say, all right, let's do the distance from S to R first. The distance from S to R squared, that's this distance, this diagonal would equal, if you drew a triangle, just do your rise and run. Use your rise and run values that you counted, kids. Rise how much?
Oh my gosh.
Run how much?
And you divide it in half, it's so obvious.
Well, you don't divide it in half. You're actually going to take the what in the end?
The 2, 2.
Square root. Okay, so watch this. Just watch this real quickly. SR squared would equal 4 squared plus 4 squared, right? Okay, well, what is 4 squared? So this means SR, the distance from S to R, squared is equal to 16 plus what? 16, okay? So the distance from S to R squared is equal to 32. What would you do to the 32?
Take the square root. And
Take the square root of that. So S to R is equal to square root of 32, right? Can you guys think of a perfect square that you could pull out of 32?
oh, you have to pull it out.
Could.
You do. I hate pulling it. It's so
The
stupid.
closest one would be.
It's so confusing to
I'll show
pull
you here in a
the
second.
root out.
You can't go 36.
I don't like pulling it.
M to N squared would equal 2 squared plus 2 squared, wouldn't it? Okay, watch this right here. What's 2 squared plus 2 squared?
8.
So doesn't that mean that MN is equal to the square root of 8, kids? Would you agree with that? Okay, watch this right here. Okay,
You take it in half. 16, 16. Yes, you do.
pretty much. Watch what happens here. Do you guys agree that 16 is a perfect square that I could pull out of
Yeah.
root 32? Would be the same as square root of 16 times square root of 2. Would you agree with that?
Yeah.
Which is equal to, what is the square root of 16? 4 root 2. Square root of 8. Do you guys agree what perfect square could you pull out of 8? 4. How many of them?
2.
What is the square root of 4?
2.
You agree with that?
Yeah.
So the distance on M to N is going to equal 2 root 2's. The distance on R to S is going to equal 4 root 2's.
It's obviously half.
That ratio is half of each other, isn't it?
But also, you don't really need to do this because if you just take the sample from how long your slope input was, just look at that.
Could. But that's going to be midpoint segment all the time. Everything's going to be half of it. So, in this case, yes. So what you end up with here, guys, is the ratio of M to N over R to S is going to equal 2 root 2 over 4 root 2, which is equal to what? What do the root 2's do to each other? What's 2 over 4 reduced to? 1/2. Okay? So you could say MN is half of what?
Oh no, that's my water bottle.
MN is half of RS there. Okay. Now I'm not too concerned about that. I want to be able to put that rule into play, but here's the deal. What's true about the slopes that are opposite of each other? These slopes are the what? SR slope and MN slope are what? Same. And then how, if I have midpoints right here, how is this segment related to the parallel segment? The short one is what fraction of the longer segment it's parallel to? Half of it, okay? So let's just look at an example here on the next page. Okay, example on the next page, or down below here, I guess. First of all, kids, what's it say down below here?
Core concept.
Core concept is what?
Triangle mid-segment theorem.
Okay. It says the segment connecting the midpoints of two sides of a triangle is parallel to the what? And it is also half as long as the side. So here it says DE is a midsegment of what? Triangle ABC down here, and DE is equal to half of AC. Okay? So we're going to do this midpoint proof here real quickly. I'm going to blow this up. It's hard for me to read this, so you guys have it in front of you. It says, write a coordinate proof of the triangle mid-segment theorem for one mid-segment. It says, given DE is what, kids? Is the mid-segment right here. You guys agree with that? Okay. We need to prove that, first of all, DE is parallel to what? And DE is half of what? Well, guys, it's pretty simple. If this is 0, 0, if this is 2q comma 2r, then what's the midpoint of going over 2q and up 2r? Isn't this point going to be q comma 1q comma 1r? What's half of 2q? What's half of 2r? To go from 0, 0 up to here, go halfway would be go 1q and... So this point D is the point q comma r. All right, well, help me out here to get to this point then. This point, working backwards, well, first of all, this midpoint, we have to use midpoints here. So the midpoint right here, guys, we would have to add 2p plus what? What's 2p plus 2q? Well, it's just 2p plus 2q, but I would have to divide everything by what? 2. So this point really is p plus q, comma. All right, help me with this 0 and 2r on the midpoint there. What's 0 plus 2r? 2r cut in half would be what? 1r. So do you agree that the midpoint here is p plus q, comma what? R. Okay. We have to prove that, first of all, the slopes are what? Okay, so let's do the slope for DE first. The slope for DE. Okay, help me with the slope from D to E. Okay, so here it would be y2 minus y1, wouldn't it? Well, what's your y2 value up here? R minus what? R. So the slope is going to equal up top, R minus R, over P plus Q minus what? Let's see what we get here. Well, what is R minus R up top, kids? I don't know. Was that okay, Adam? Okay. What is R minus R, class?
0.
0 on the numerator. Kids, in the denominator, I have P plus Q minus Q. 0 over P would equal what for a slope, kids? Zero divided by P. 0! Yep. So the slope from D to E is what? 0. And that kind of makes sense because we thought that line was horizontal anyway to begin with, didn't we? Let's do the slope from, to prove that DE is parallel to OC, we're going to have to show that OC also has a slope of what? Here we go. y2 minus y1. So from these 2 points, O and C, what minus what? What minus what for y2 minus y1? 0 minus 0. That's good because up top you already know you're going to have what? x2 minus x1. So 2p minus what? So it's going to equal 0 over 2p. But again, kids, what slope do you get? What do you notice about the slopes here? They are the same, aren't they? They're both 0. Therefore, the lines must be what? Since slopes are the same, the lines are, we've shown that already. Okay, good. Now, we need to show that DE is equal to half of what? Okay, let's do the distances here. I'm going to make a little t-chart. So I'm a little t-chart. Hear me, math. All right, let's math it up. Let's do the distance from O to C. Kids, if you mess up the distance from O to C, I'm going to throw a tantrum. It's a horizontal line, so you're counting.
1, 2.
Well, no, you start. What's the x value down here? We're going horizontally, right?
To 2p.
2p.
So it's just 2p.
It's just 2p.
Okay, wouldn't the distance right here be p plus q minus this distance q? Or if I did distance formula would say, take this minus this, square it, this minus this, square it. So the distance formula would say, do this.
How do you write it?
Don't worry about it. What are the q's going to do right here?
0.
They're gone. Hey, what are the r's going to do?
Nothing.
They're gone. This is really going to equal the square root of p squared, isn't it? Well, what's the square root of the squaring function going to do right here?
Distance equals p.
Distance is just going to equal p.
P equals p.
So right in this right here, kids, I can come back and say, well, this distance would equal from D to C would equal P. What fraction of 2P is 1P?
We got a mind blown here.
So DC is half of what? Since this is half of this, DC is half of what? We've shown it right there. Okay, is that what they want you to show? Okay. Let's jump into a diagram, see if we can't figure this out. 43. We're hustling. Here we go. Ready? Very top up here. It says here's the mid-segment theorem, triangle mid-segment theorem. DE is the mid-segment of what, kids? What do we have to find? A to C. Well, what's true about E to C then, kids? It's 4.8 also. So the distance from A to C would be what plus what?
Probably you would get the it'd be 5 points. Wait, wait, 5.6 plus 8 would be 9.6.
Yeah, where's 5.6?
Well, you just add.
Do you understand this is 4.8, so this must be what? 4.8 to get from A to C, you just add those two distances.
I got it right though. 5.6 plus 4. Wait.
Plus 4.
Plus 4.
Okay, here we go. Right here, kids. In the kaleidoscope image, AE is equal to what, kids? Midpoint, right? AD is equal to what?
Wow. Oh my gosh, I remember these things.
AD is equal to CD. It says show that CB is what? CB is what?
Parallel to
It has to be, doesn't it? Because isn't this just midpoint segment?
Yeah.
Slopes would be the same. By midpoint theorem, D is a midpoint of this side, and E is a midpoint here. So since these two are midpoints right up here in this triangle, DE must be parallel to what? CB down here. I would just say by mid-segment theorem, okay, and again, we know that if these are, if AD is equal to CD, D is a midpoint, right? And if we know that AE and EB are equal, that's a midpoint, right? So by mid-segment theorem, we can say that DE is parallel to what? And I'm not going to write the whole thing out. Right? You should be able to understand that. Mid-segments parallel to the side opposite here. Forgot the part of the E. There. So it says in the figure example, CF is equal to what? CF is equal to what, kids?
FB.
It says CF is equal to FB. I'm going to get rid of these marks up here, but CF is equal to FB right here. These two are equal, CD and DA right here. So which two lines must be parallel, kids? DF with what? AB. DF and AB.
Back.
Okay, last example quickly. We're going to get this done, shockingly.
There's
Yeah, 'cause
another,
we
there's,
spent a lot
another,
of time.
there's one more on the back.
Hey, you just got that example done.
Okay, last example. Ready? Oh, no.
Oh, I have one.
This is very simple, though. It says a walking path from B to where?
D.
In a park intersects the sides of the park at their what?
Midpoint.
Which means that BD is a mid-segment over the path to the other side of the park to corner E. All right? And then back to your starting point. How many yards will you walk? You're going to walk from here to here to here and then back. Okay? We have to figure out this distance right here, kids. Well,
Really?
we're going to start where? You walk a path from what, kids? A to BD to the other side of the corner, E, and then back to your starting point. How many yards do you walk? Well, here's the path we're taking. We're going from A to here, and then back again. What's the distance from A to B, kids?
90.
By mid-segment, 90. Okay. What's this distance up here? And how do you know? What kind of point is D? So what's half of 216? So the path to 90 plus 68, how much is that? 90 plus 68 is 158 plus the extra 108. But we have to return, kids, so we're going to times that whole mess by what? So 158 and 108, that's 266. But we need to take 266 times what since we returned? It's like walking the path twice.
2 times 266. Okay. I'm so good at mental math.
So it's 500.
566 plus 6.
500.
I'll send it online out. You guys have a great
You
day.
can't do that.
I can